Hello everyone, in today's lesson video. By the way, welcome into today's lesson video. If you are new to the channel, please just click the red subscribe button. Please subscribe. In today's video, we're going to be looking at Newton's calculations, Newton's second law. This is why we're going to be looking critically on how to tackle questions that say calculate the tension force and okay. Yes, please don't forget to subscribe, guys. Please subscribe right now. Go and subscribe. Thank you so much. Let's get into the topic. Okay, so in this situation we are given that okay, so this system, I try to draw it for you guys. So a 10 force is used to pull a toy train. Okay, yes. So this is your toy train moving westwards. Okay, yes, moving to the left hand side, which is pulled, or the force, yes, which is pulled by 10 newtons. Okay, this is the force applied, by the way. So which has an engine. Okay, this is our engine and a cart attached. The train engine has a mass of 1 kg. So our engine has a mass of 1 kg. And mind you, this is a connected system. And the cart has a mass of 500 grams. Okay. Okay, the very first thing you have to, okay, I'll explain this later. The track is smooth and therefore there is no friction. So the track is smooth. Okay. The track is smooth. There is no friction. Okay. There's no friction here. So the very first thing as you are reading, you have to regard is this 500 grams. Okay, yes, so that you can work effectively. Okay, yes. So you have to convert this, okay, grams to kilograms. Okay, yes, because you can't substitute your grams into our mass. Yes, you have to first change it to be kilograms. Okay, so let's do that. So in order for you to change grams, okay, grams to kilograms, you have to do what? You have to divide by 1000. Okay, yes, you have to divide by 1000. So divide is, say, 500, divide by 1000 and you'll receive your kgs. Okay, yes. So let's say 500 divide by 1000 is equals to 0.5. Okay, so your grams 0.5. okay, 0.5 kg. Okay, yes, please don't forget that. Got that. And I was supposed to explain this while we're calculating, but I just thought of, hey, what if I forgot to tell you? But I was going to tell you by the way. Okay, so for our answers, draw a Freeboot diagram for an engine. So let's draw a Freeboot diagram for an engine. Mind you, engine is this. Okay, this 1 kg. Okay, object. Okay, so let's make a dot. Dot, mind you, must be quite big all the times. Okay, it must be not small. Okay, like this. Maybe might be not small like this. It might be like quite, okay, bigger like this. So there's a force, okay, applied, as you can see. Okay, first of all, it's on the surface. There's a normal force acting on it upwards. There's a normal force on it upwards, and also you have a gravitational force. You have your Fg, and you can see that there's applied force, which is equal to 10 by the engine, 10 newtons. Okay, this is the applied force, and you can see that the engine, okay, is pulling the cart, meaning that there is a force, okay, a tension force that is applied by by a cut to this engine, pulling it backwards. So there is an opposing force, okay, which is our Ft, is given there, okay. Yes, so this is our free body diagram. I think I've shown all, yes. So this is our free body diagram. So let's mark and check it. So this is our normal force, okay, it's on the ground. Normal force, gravitational force acting downwards, its weight, okay. Gravitational force is equal to weight, by the way. You're supposed to say, okay, yes, you can also say this, or say this is equal to, you can also say it's equal to mg is equal to weight, okay. That's how it goes. We have Ft, okay, Ft, which is pulling back this engine, okay. We have applied force, okay, which is 10 newtons applied by the engine to move the train, okay. So that's how it goes, guys. So let's jump to our question 2. Let's calculate now. Okay, so for question 2, okay, so calculate the acceleration of the train. Now they ask you to calculate the acceleration of the train. Mind you, this is a connected system, this is the engine, and this is the kite. All of it combined, it's a train. So meaning that, mind you, again, they are emphasizing the fact that a connected system of 2 or more objects will have the same acceleration, okay. Yes, so meaning that we are going to calculate we are going to form 2 equations here, for this one, for the train, okay, and for the engine and for the kite. So let's start for the engine, okay. For the engine. So for the engine, we have the net force is equal to ma, okay, mass times acceleration. What are your net forces acting there? We already showed into our free body diagram. Mind you, free body diagram are very important in showing all forces, okay, acting on an object, the net forces. Okay, so you have the applied force that is being opposed by the tension force. This is equal to ma. What's the mass there? The mass is 1 kg. It's 1 multiplied by acceleration, okay, then we have acceleration. So we have 10 minus Ft is equal to 1a. This becomes our very first equation, all right. Yes, so let's calculate for the kite. Let's calculate for the kite right now. Okay, so we have your net force is equal to ma, and this gives us the net forces acting on that kite. Okay, let's draw a free body diagram for the kite here. Free body diagram for the kite. You can see the kite is moving this way, okay, the motion, meaning that the tension is favoring the motion of the kite, meaning that it's positive. Tension is positive. It's on the surface, there's a normal force acting on it, there's a gravitational force acting on it, meaning that we have your Ft is equal to ma. What's the mass of that object? It's 0.5, okay. 500 grams divided by 1000, this gives us 0.5 a, and this becomes our second equation. So let's substitute our second equation into our first equation to find the value of a. So this becomes 10, okay, minus Ft is equal to 1a. Okay, let's substitute this one into this. So this becomes 10 minus, what's our Ft? Our Ft is 0.5 a is equal to 1a. So this becomes 10 minus 0.5 a is equal to 1a. So therefore we have We're going to take our 0.5 that side and it becomes 1.5, right? Yes, it becomes 1.5. 1.5a. Okay, we left to 10 this side, so divide by 1.5. So do you mind please guys divide 10 by 1.5? So 10 divide by 1.5, it gives us 6.67. Okay, yes, 6.66667. okay, that becomes 6.67. we round it off. 6.67 meters per second. This is our answer for our acceleration. Okay, and our answer is correct. Number 3, calculate the tension of the train. Okay, the tension. Okay, let's calculate now the tension. There are so many ways we can calculate the tension. We can either take your acceleration and substitute to one of the equations, in whether to this equation or to this equation, okay, to get your tension, okay. Or you can just say use your engine, okay, your engine. F net is equals to Fa minus Ft. Okay, Fa, it's a known value, this is unknown value, and this is a known value, acceleration. So you're going to be left by Ft unknown, and you can find your Ft. So let me do it for you guys. Let me start with which one? Let me start with this one. Okay, and mind you, your acceleration will have a big impact on your answer. So take the acceleration, okay, take the acceleration that is the same, or take the acceleration that was recurring numbers 6667 on your calculator, okay, yes, and substitute into one of these. So let's substitute on which one? Let's substitute on 10, okay. So let's say on our equation 1, let's say or on our equation 2, right? Let's use equation 2. So Ft is equals to 0.5a. So this becomes is equals to, what's 0.5a? 0.5. Okay, substitute 6.67. okay, or you can substitute 6.6. you can press on your calculator. When pressing on your calculator, substitute that 6.67, those recurring numbers after the comma, so that you can receive appropriate answer. So this gives us okay, let's press on our calculators. Okay, so multiply by 0.5 is equals to 3,33333. okay, so our tension force is 3,33 newtons. Okay, let's use another one, and mind you, how did I receive my 3,33? So if I say 0.5 multiplied by 6,666, the answer that you get when you divided 10 by 1.5, our real acceleration, okay, yes, which is the same as this one, but you want appropriate this, our answer must be the same, okay, yes, so that you can be more certain. Okay, so okay, let's use Fnet right now. I'm just proving for you, so you can also use this way. Fnet is equal to ma. So Fa minus Ft is equal to 1a, right? Yes. So this becomes 10 minus Ft is equal to 1 multiplied by 6.67. This becomes 6.67 this side. 10 minus Ft, so we take our 10 that side. So okay, so minus the 10, okay, so that you can get, so this becomes okay, let me first take this one. We said 10, right? When you get acceleration divided by 1.5, yes. Okay, so take that acceleration as it is, onto your calculator. So say minus 10, okay, minus 10, 6,667 minus 10, minus 10, that gives us negative 3,333, okay. Our negative ft is equals to negative 3,33, and therefore our tension force, you can see guys, therefore our tension force is equals to 3,33 newtons. Please don't forget units, okay. Yes, so that's how it goes guys. So you can use either this way or this way, okay. Yes, that's how it goes. I think you understand and I trust you. Okay, I think we're done. 1 2 3 in the morning, 2 3 guys. Thank you so much. I'll see you in the next following video. Cheers. Sure.